Hi, Dr. Phil Harris here, and today I want to talk about the internal rate of return. What is it? How do we use it? And how do we calculate it? Well, you can see I have an example here, and it shows that we've got a discount rate of 14%. And you can see in parentheses I have WACC, which stands for the weighted average cost of capital. And what that is, it's the mix between debt and equity that it takes to raise the money that we need to invest in the project. And then you can see if we come down here, we have an initial investment, and you can see it's negative. That means it's going out. It's $853, and that's in time period 0, which means that's today. So in other words, we have to invest this 853 today to get these positive cash flows coming in during the next 7 years. And then we have our internal rate of return. So what is internal rate of return anyway? Well, internal rate of return is the net present value that's equal to 0 to get these cash flows to come out to 0 to that net present value. So we can state that by a formula. So it's the sum of the cash flow for period 0 plus the cash flows for period 0, and in this case 7, but I'm just going to use n because there's 7 periods, and then we're going to divide that to discount it by 1 plus the internal rate of return, and that again is going to be to the 0 to the nth power. Okay, so that's what it is. And we can say it another way. We can say NPV has to equal 0, okay, which equals cash flow, which is our initial investment at period 0, plus the cash flow for each of the other periods. So here's period 1, and that's 1 plus IR to the first power, because that's for period 1. And then in period 2, we'd have cash flow of period 2. And again, we're going to discount that, so we have to discount it by this internal rate of return. And then what we can do, so we don't have to go off the end of the page, I put these little dots, and that means continued. And we'll take that out to cash flow for period 7. And again, that'll be 1 plus IRR to the 7th power. So that's the equation that defines the internal rate of return. And what we're really doing, let me change the color here, is we're trying to calculate what this value is right here. What is this value? And if we work this out, we could do it, but that's pretty sophisticated math, and it takes a lot of time. And a much better way to do it is to use Excel. And that's what I did here. So now I'm going to get rid of my pen, and I'll show you how to do this in Excel. So the first thing you have to do is you have to highlight the cell where you want to put it. And let's get rid of this 2309, and you can see what I mean. We're going to calculate that 2309. How did I calculate it? Okay, so we put our cursor in that cell because that's where we want that internal rate of return to go. And then we come up here to our function bar, and it opens up a box, and it asks you to search for a function, and if it's not so obvious like it is here, it comes right up. These are all financial functions here. And so if we find internal rate of return, we could put it in up here and it would find it for us. And then we click OK. It'll open up this function box, and it asks us for values. And this is how simple it really is. If we highlight all the values in our formula, which is cash flow for period 0 through 7, and it puts them right out here just like it is here in our spreadsheet, it automatically calculates our internal rate of return. You can see it's 0.30893817, which is not as good as putting it in a percentage because it's a little easier to compare it with our discount rate. And you see that down here. So all we have to do now is click OK, and that's how simple it is to use Excel to calculate internal rate of return. So I hope this video helped and explained exactly what it is. And as long as internal rate of return is greater than the cost of capital, you'd accept the project unless you're comparing with another project, and then you would of course take the project with the higher internal rate of return. So that's it, and I hope to see you in my next slide.